Okay, Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon to all of you. Uh, okay, I hope you are in good condition, and I think maybe several of you got affected by the recently heavy rain in Selangor, Shah Alam, especially in Shah Alam and Klang. And I think also Malacca also, because I went there, two states, uh, several, I think yesterday. So I just come back in Johor Bahru, and it's raining. I think yes, 2 days. It's been 2 days, and itulah. I hope those who got affected can actually banyak-banyak bersabar lah. Okay, so because I have a sister that resided at Klang, and her house got flooded. Itulah, a lot of things happened last week. Okay, I just want to go very quick on this auto transformer and the three-phase transformer, which is I have already pre-recorded. So I just want to know whether there are some maybe problems on understanding this subtopic, okay, the auto transformer and the three-phase transformer. As mentioned before, this topic is not our main topic in the syllabus. It's just a briefly introduction about the auto transformers and also the three-phase transformers. Okay, so our main after this, our main topic will be the power generation. Okay, the power generation and also the power transmission, which is will be in your second test. Okay, the question is still not prepared yet, but I will update you on the questions. Okay. Okay. So just a quick overview on this transformer. So this is actually the auto transformer. It's actually not what you call a transformer for isolation. Okay, it is more towards on to have a variable voltage output. Okay, so this one is actually if you enter the machine lab, I think maybe uh next two semesters, I think, or maybe in this semesters, you should enter the machines lab. If not mistaken, I don't remember whether you are. I think you are the second year, right? The second year student. Have you entered the machines lab? Machines lab.
No, Doctor.
No, sir.
I haven't.
Okay, so meaning that another two semesters you will be entering the machine lab. So inside that machine lab, so actually the power supply to the machine, the induction motor, is actually a 415 volt fixed voltage. Okay, so but in order to see the performance of the motor, so we need to have a variable input voltage. Okay, so we need to have a variable voltage to the induction motor. So we are using this what we call auto transformer, or sometimes it is popularly known as a variac. This one is actually vary plus AC, so variable AC voltage. That's why we call sometimes variac. Okay, so it depends on the capacity. So for small voltage, you can have it a very small size, but for the high voltage, for example, 450 volt, you will have a very high, big size of this auto transformer. Okay, so actually, there is no isolation, okay, between these primaries. It's just for the what you call just to provide the variable output voltage. Okay. this is actually the equation. So this is actually, as you can see, is actually just a tap actually. You have a coil and then just you tap, for example, this one N1, okay, this one N1 plus N2, okay. So and then for the upper voltage is actually you just tap between this and this. So this one may be N2. So this is just a portion, a percentage portion of the whole range of coil. Okay, for example, this one. So this one is one N1 plus N2 is actually called 100%. Okay, and then N2 is actually maybe 20% from the total tap, from the total range here. Okay, so it depends on step down or step up transformer. So for the step down transformer, this is the equations. So meaning that for the primary side, you have a larger portion, while for V2 is actually just a V2 N2. Okay, you mean, as you can see, is actually the portion of the total winding. Okay, so that is the step down for auto transformer. And for the step up auto transformer, as you can see here, V1 is the only a portion of the total coil. Okay, total coil. So and then we have an example here. As you can see here, we have what I call, this one is a 40% tap from the input voltage. So the secondary voltage is actually just a 0.4 multiplied with V1. So you should get around maybe 160 volt. It's simply like that. It's just a what I call adjustable AC voltage output. Okay, and then from the secondary current and primary current, you can use that based from the rating of the transformers. Okay, so this is the solutions. As you can see, is actually just a tap. Okay, ratio meaning that this is actually 0.4 or 40% from the total winding. Okay, any question regarding the example here? So auto transformer is just what I call just a variable upper voltage adjuster. Okay. Okay, and then we go for the three-phase transformers. So any questions regarding the three-phase transformer? So as you can see, it's just only what you call a theory. So for the three-phase transformer, we have Y to Y connections, Y delta connections, delta delta, and delta Y. Okay, but usually for Y and Y connection, this one is very rare. Okay, the popularly used is actually Y delta, delta delta, and also delta Y. And for the delta Y, it is used as a step up transformer in a generation station. Okay, and for delta delta is actually used in a medium voltage, and for Y delta transformer, it is used to step down the voltage. Okay. But compared to these three-phase transformer, the delta delta connection or delta delta transformer is has some advantage. Okay, because as you can see here, it can actually remove one phase, okay, from the operations. Okay, so this is actually the connections of for example, this one is Y to delta connection. Okay, so this is Y and this is delta connections. And this is the configurations. Step down. Okay, step down. This is Y to delta, and then this is delta to Y, and this is delta to delta. So delta to delta, as you can see, you can, for example, you can remove this. Okay, you can remove this one phase from the operation, and it still can actually operate it. Okay. And usually for the three-phase system, okay, if the load is balanced, which is usually a typical case in power transmission and power generation where all the system are balanced. Okay, so usually the analysis will be conducted in a single phase. Okay, so a single phase, to have a single phase, what you need to do usually is actually to convert uh, the connection into Y connection. Why Y connection? Because Y connection, we have what we call the neutral point here, N. Okay, so neutral point here. So that's why. For delta, there is no connection, there is no neutral point. So we cannot actually use this delta to have what we call a reference node. So usually for to have a single phase equivalent circuit to represent the three phase, what we need to do is actually to convert delta into Y connection. Okay, for example, as you can see here, the load is a three-phase load, balanced load. So you can just transform by using this formula. Okay, so the load right now, as you can see, has been transformed into Y connection. And right now, as you can see here, the secondary part is at the delta, original delta. So you can use, uh, I think, an equation. Okay, just divide by 3, so you can have the equivalent Y connection. Okay, for the secondary. And after you have obtained this, and then we consider that all system are balanced, so you can just use a single phase. Okay, for example, phase A as our analysis. Okay, so right now, as you can see, we are using the voltage phase right now, voltage phase. So all actually, this one is also a V phase. This one is also a V phase. Okay, we cannot use V line to represent our single phase equivalent circuit. Okay. And this is actually when you have delta to delta connection. So when you have the delta connection, you can either open up one phase, a single phase, okay? One phase, for example, you open up the phase C here, phase C, you open up, okay? So still the transformer can operate it, but it only, the capacity is reduced to only 58%. So meaning that the rating has been reduced, okay, by half, okay? So still can operate it, but the what you call the highest performance only 58% of the total original capacity. Okay, so why delta to delta is actually a very good option usually in a transmission or in a usually in the transmission. Why? Because actually we can use only a two phase only. Okay, for example, if in the future, in the current situation, they are not required a total three-phase transformer to power up all the loads. Okay, so meaning that maybe only only two phase is enough to power up all the power demand. But in the future, maybe the load is demand is increasing, so it just put back the phase C, for example, so that it can operate it in its full capacity. Okay, so this is actually the reason why we can open the data transformer. Okay, for example, when the current load is too small to warrant a full three-phase transformer system. For example, the load demand is very small, so you can actually take out one phase, so only operated in the two-phase system, then it's okay. Okay, another one is actually for the maintenance purpose. Okay, for maintenance purpose, meaning that you want to maintain, because the transformer you need to maintain. Okay, we will go after this why the transformer need to be maintained, because actually the transformer need to be oiled up, okay, because the operation is require some oils and so on, so we need to refill or what you call replace the oils, okay. And lastly is because when it is anticipated that the future is increased from the current situation, from the current load, okay. And this is actually the construction of the three-phase system. So I think this one, I just go quickly. Okay. Okay, this one. there are two types of transformer. The first one is the oil transformer, and the second up is what you call the dry transformer. So for oil transformer, usually where there is a special transformer that requires oil as their what they call coolant. Okay, so that coolant must be replaced in interval time. Okay, so that's why so we need some maintenance. So meaning for delta connection, delta to delta connection, you need to always have the maintenance so we can open up one phase and then another phase and so on. Okay, to have the maintenance to be made. Okay, so I think this one usually for the oil transformer, usually it is a very high capacity transformer. Usually you can find it in the transmission power plant, okay, where you have the transmissions there. So you usually will see this type of transformer. Okay, this one is a what you call a oil type of transformer. And then another one is actually a dry type transformer. This one is for usually for the small capacity transformer. Okay, small capacity transformer, and this actually is actually the coolant is actually from the air, so it radiates its heat to the air, so it requires no oil to as their coolant. So, but this one is only for the low power applications. Okay. Okay, I think that's all from me. Any questions regarding this transformer, the three phase? So as mentioned before, this is just a theory. Okay, and then for in my experience, it will not be tested, has not been tested in final exam or in final exam also test, second test. Calculation. So calculation for our syllabus, we have no calculation. For this syllabus, there is no calculation for this three-phase transformer. So this is only for introduction, just what I call a brief introduction about the three-phase transformer. Okay, so that's why sometimes there are certain books that have a calculation for three-phase transformer and so on. But for our syllabus, we limited our syllabus for three-phase is just for what I call a theory, just a theory. Okay. So that's why sometimes it's quite difficult to have what I call a single textbook. Okay, because our syllabus is quite what I call rojak lah. It's actually a mix of different books because we need to have a different objective to tackle. Okay, to tackle in this course. So that's why. Okay, so I think this topic is no problem lah because we don't assess the students. Okay, we will not assess the student. For in my knowledge lah, in my previous, I have been teaching this course. This topic has not been us, okay, in final exam or in the test. So, okay, so if there is no question, I think I leave you with the pre-recorded video. I am sorry because this note I haven't shared last week. Okay, so I have shared it in the WhatsApp group and also the e-learning. And okay, and then after this, what you need to do is to watch the pre-recorded video that I have prepared for the next topic. Okay, this is the second topic. The first topic is actually the AC power. The second topic is actually the magnetic circuit and the transformer. So this is the last part of the transformer. So we go for the third topic or third chapter, which is the power generation, transmission, and load profile. Okay, so that one I think maybe 3 weeks. Okay, will consume you about 3 weeks or maybe 2 weeks and a half because we have another last chapter, chapter number 4, which is the AC machine. Okay. Okay. So I I think I haven't yet share in the my YouTube channel. So after this, maybe I will share with you. And the notes, okay, the notes for the third chapter, which is the power generation, transmission, and load. I have already share in the e-learning. Okay, so you can download all the power generation, power transmission, and load profile notes from there. I have uploaded all. Okay, so so I think that's all. But just to have you a glimpse of the. So let me. The notes, okay, of the next topic, which is this one. Oops, sorry. Which is quite extensive actually. Electricity generations. Okay, so this is actually quite this is not electrical actually. This is more towards on mechanical, the combination of mechanical, chemical, and so on. So you need so actually all the calculations is quite you need to adapt yourself because we are dealing with what we call for example calories, joule, kilowatt hours, and so on. And for example here I in my notes I have highlight 1 kilowatt hour is equal to 860 calories. Okay, this one is calories. So in general in general energy, it is calculated as joule, and because energy actually we have a lot of energy. Okay, for electrical energy, usually we measured our energy in unit of kilowatt hour. And but for the heat combustion, for example, our coal and so on, so they are calculated the energy in terms of the calorie because it burns the what we call the coals and so on. So it measure the energy in the unit of calorie or KCL. Okay, so in 860 calories is equivalent to 1 kilowatt hour um, electrical energy. Okay, or and then so right now I ask you what is 1 kilowatt hour, what is equal to joule. So I think from the video I have already discussed that. Okay, so meaning that you need to adapt yourself. So right now, as you can see, we have quite new parameters. Okay, so you need to brush up back your physics and so on. Okay, so and then this actually the calculation of all the examples is quite limited. Okay, it's quite limited. So usually we are only focusing on the maybe maybe example from the slides and so on. Okay, so we have the first one, we go for the thermal power stations. The second one is the hydroelectric station, and more towards on the physical part, and then the calculation of the energies from the hydroelectricity. What is the total of amount of energy that we can extract from the hydroelectric stations? And then I think lastly is actually the gas turbine power station. Okay, which is these three power generation station is actually the major power generator in Malaysia. Okay, so this one gas turbine, I think there is no much information, just a brief explanation. And then wind power, solar, and so on is just brief information. Okay, so meaning that our main, for example, for your second test, the question will be from the hydroelectric and also the thermal power plant. Okay, so I think that's all from me. I will share you the link of the YouTube that I will share after this in the WhatsApp group. Okay, any questions?
Doctor, I got a question, but like it's off topic.
Okay.
Doctor, do you have any idea if this next semester is going to be online or face to face? Because we want to see those stuff and experience them in real life.
You mean the class?
Yeah, classes.
We don't have any final answer from our superior, from the faculty and so on, because right now they are silent. But I think it will be 100% online throughout this semester,
Okay, sure.
because the final exam will be online.
Okay, sure, definitely.
The final exam will be online. Okay.
Thank you.
But please be remembered that since this is online examination and most of you are in UTM, most of the locals Malaysian maybe they have entered the campus, and please for the test and the final exam, please don't cheat. Okay, because we know that you are in the maybe in the same room, so you have the possibility to cheat and to what you call uh, to have a collaborator, okay, to answer the question. So uh, please we remind you on that, and also don't upload any question to the online platform, because not this subject, not this course, but recently we have detected one course that have already upload the first test question in online platform, which is check.com. So still uh, a student, still the students actually very brave enough to actually upload the questions. Okay, so I just want to remind you that we have the tools and software that can detect all the possibilities, okay, the online platform and so on, that we can actually use that to detect any plagiarism and so on. Okay, I think any questions, or maybe anything that you want to share before I dismiss this class? Okay, so if there is no question and okay, so I think we dismiss this class, and please proceed. Okay, after this, I will give you the link for this pre-recorded video of the power generation. Okay, thank you very much, and Assalamualaikum.
Thank you, Doctor.
Okay.
Doctor.